There's one more property that we would like the norms that we work with to have, the matrix norms, that not all matrix norms do have. Let me illustrate. Let's go back to linear transformations. So we have a linear transformation LA, LB, LC, taking vectors from one size to another size, but in such a way that you can compose LA with LB to create the linear transformation LC. We saw that that's equivalent to saying we have a matrix A, a matrix B, and a matrix C, and C is equal to A times B. Now, think about linear transformations. I think of linear transformations as taking vectors, maybe taking them to another dimensional space, stretching them, making them point in another direction, those kinds of operations. So, what does that mean? What am I trying to say? LB takes a vector x and at most stretches it a certain amount. Then that result vector is fed into LA and is transformed into a new vector, possibly stretching it some more, or maybe even shrinking it. What we would like is for the net stretching to be no more than the maximal stretching that B does times the maximal stretching that A does. Maximal stretching that LB does times the maximal stretching that LA does. How do we capture that? We would like our norm to have the property that the norm of A times B is no more than the norm of A times the norm of B. Right? The norm of B measures the maximal stretching that B can do. The norm of A measures the maximal stretching that A can do. Multiply them together. We want something bigger than the net stretching that the matrix that results from multiplying A times B does. Okay, now it turns out not all matrix norms have this property. The property is called submultiplicative norms. The property is that the norm is submultiplicative. The norm is said to be submultiplicative. Alright, so fortunately all of our favorite norms, the Frobenius norm, the 2 norm, the 1 norm, the infinity norm, all do have this property. And we're going to see that this is going to play an important role in the theory that we're going to develop soon.